All right, class, in this video, we are covering section 4.4 in your textbook, the laws of logarithms. And so we're starting at the top of page 2 of your lecture handout. So here we're going to evaluate some logarithmic expressions with real numbers using the laws of logarithms. And we're going to be using those laws in reverse order. So you know that with an equation you can switch the two sides of the equation, and so the product rule was presented to you as log of a times b is equal to log of a plus the log of b. Well, if I switch the two sides of that equation, I have the log of a plus the log of b is equal to log of a times b. And we'll do the same thing with the quotient rule and the power rule. Right, we're going to switch the two sides of the equation. So top of page 2, we have to evaluate the common. Now there's no base given on the log, right? So we know that this is the common log, log base 10. And so we have the common log of 500 plus the common log of 200. Well, from page 1, we switch the two sides of the equal sign. We know the common log of a plus the common log of b is equal to the common log of a times b, right? That's the product rule, right? Two sides switched. So this is equal to, right, following the pattern over here, this is equal to the common log of 500 times 200, and 500 times 200 is 100,000. And so the common log of 100,000 is equal to 5, because 10 to the 5th power is equal to 100,000. Remember, the common log has a base of base 10. In the next example, we're going to find log base 6 of 18 plus log base 6 of 12. Again, we can, right, this is an addition, so we're going to use the product rule. This is equal to log base 6 of 18 times 12, and 18 times 12 is 216. And log base 6 of 216 is equal to 3, because 6 cubed is equal to 216. So this sum up here, log base 6 of 18 plus log base 6 of 12, is equal to 3. And in our first example, the common log of 500 plus the common log of 200 is equal to 5. In the next example, we're going to be using the quotient rule. Log base 3 of 123 minus log base 3 of 41. What's that equal to? Well, from page 1, when we flip the two sides of the equation, we have log base 3 of a minus log base 3 of b is equal to log base 3 of a over b, right? A goes in the numerator, b goes in the denominator. So the difference, log a minus log b, is equal to the log of the fraction or quotient a over b. So log base 3 123 minus log base 3 of 41 by the quotient rule is equal to log base 3 of 123 divided by 41. Well, 123 divided by 41 is equal to 3. So this is equal to log base 3 of 3, which is equal to 1, because 3 to the 1st power is equal to 3. So log base 3 of 123 minus log base 3 of 41 is just equal to 1. Lastly, we're going to use the power rule to evaluate 1/5 times log base 3 of 343. So again, from page 1, switching the two sides of the equal sign, we have c times log base 3 of a is equal to log base 3 of a to the c. This constant out here, this multiplicative constant c, can be brought inside the logarithm and made an exponent on the number a. So c times log base 3 of a is equal to log base 3 of a to the c. So 1/5 times log base 3 of 343 is equal to log base 3 of 343 to the 1/5 power, right? That 1/5 is brought inside the logarithm and made an exponent on the number 343. Well, 343 to the 1/5 power You remember our discussion from rational exponents earlier in the semester, is equivalent to the fifth root of 343. Well, the fifth root of 343 is equal to 3, and so this is equal to log base 3 of 3, and from up here we know log base 3 of 3 is equal to 1. So 1/5 times log base 3 of 343 is equal to 1.